I'm going to solve quiz 2 of unit 9 that says like this. A large sheet of conducting material located in the xy plane as shown in the figure that I will draw in an instant has a uniform current flowing in the y direction. The current density is 1.5 amperes over centimeter. Use Ampere's law to calculate the direction and the magnitude of the magnetic field just above the center of the sheet. And be careful, do not use the edges of the sheet. So we have here our sheet with our current vectors that are pointing toward that direction. And we have our current density that is equal to 1.5 amperes over centimeter. And we know that this is the y-axis and this is the x-axis, the y and x. So we have to calculate here the path, but don't using the edges of the sheet. So I'm gonna draw it in here. We will have a path and we will have here our current vectors that are going toward that direction. And we can establish that the direction will be in that direction. We will have one magnetic field that way and other magnetic field that way, and we will have the length of our path in here. We will have 4 edges. Here we have first edge, then the second, then here the third, and here, well, 1, 2, 3, and the 4. Okay, once we know this, we can establish the Ampere's law that says that we can have the integral of the magnetic field times ds, and this will be equal to mu naught times the enclosed current. So for using this formula, we are going to use only the edges 1 and the edge 3. So we will have that this it will be equal to the integral of b ds, that is equal to our magnetic field in B1 times L, that is the S, it's the part, the little piece that we are using of this is the ds is the little piece we are using of the sheet. In this case we are considering only the length of that piece. That's why we are using here L plus B2, that is this part here, times also the length of that specific part of the path. And this will be equal to mu naught times the current enclosed. But we know that the current enclosed will be established by this formula. So as we know that the current density is equal to the current times the length of that specific part we are working with. So if we work with the current, we are left here with the current times the length, and as we can see here, the length is cancelled because we have it in all our terms. And we know that the current density is equal to 1.5 amperes. So here we have 1.5 amperes. Okay. Once we know this, then we can say that B1 will be exactly the same as B2. They are equal. So we can say that 2 times B1 will be exactly the same as mu naught times the J. Okay, so what we want to know the value of the B, that is our magnetic field. So the B, our magnetic field, will be equal to mu naught times our density current over 2, and we only have to substitute our values. We know that mu naught is equal to 4 pi times 10 to the minus 7 Tm over A amperes Tesla, and here is the current, density current is 1.5, so we know it's times 1.5. But here we have that this will be in amperes over centimeter. So here we have amperes over centimeter. But we wanted to calculate in meters. So we know that 100 centimeters is equal to 1 meter. So we cancel the centimeters and we are left with meters, and this over 2. Here is the 2 over 2. And this will be equal to 9.4 times 10 to the minus 5 Tesla, and that is the result for this quiz.